Okay, Wildcats. Today we're looking at Wednesday, September 19th, Thursday, September 20th, and Friday, September 21st. Okay, so we're going to start with solving absolute value equations part 1. That's going to be on page 9. Then we're going to talk about solving absolute value equations part 2 and solving absolute value equations part 3, and that's going to be on page 10. Okay, so if you would update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right. So this is going to be on page 9. This is going to go in your journal binder. Solving absolute value equations, part 1. Definition. The absolute value of x is equal to x positive when x is greater than or equal to 0, and negative x when x is less than or equal to 0. The key is when you have the absolute value of x, you have positive and negative. Okay? And I'll explain that in the solving steps. Step 1, isolate the absolute value. Step 2, apply the definition. That's where we're going to apply the positive and negative aspect of it, okay? Step 3, solve. Step 4, graph the solution. Now you have types of absolute value function solutions. There's one solution when we have the absolute value of x is equal to 0. You have two solutions when the absolute value of x is equal to a positive number, and no solution when the absolute value of x is equal to a negative number. So if you would update your notes. All right, now your notes are updated. Let's take a look at the examples. Solve the absolute value equation below. So step 1, isolate the absolute value. It's isolated. Step 2, apply definition. So that's where you have x equals a positive 3 and x equals a negative 3. Now solve. It's already solved for, so you are done with that part. Now step 4, graph the solution. So we graph a number line. Now, whenever you do a number line, you always put 0, okay? That separates the number line into negative and positive sides. So you have the negative 3 right here and a positive 3 right here. And that's the only numbers you need, okay? You don't need to put tick marks for all negative 1, negative 2, negative 3. The 0 tells you the negatives on the left, positive on the right. All right, example 2. Step 1, isolate the absolute value. So we're going to add 1 to both sides. You get the absolute value of x. This is 0 equals negative 2.5 plus 1 is negative 1.5. You're left with absolute value equal to a negative number, so we know there's no solution. Now, what that looks like on the number line is there are no points on the number line, so there's no solution. Okay? Example 3. Isolate the absolute value, step 1. So we're going to subtract 3 from both sides. So that becomes 0. You get absolute value of x. 3 minus 3 is 0. So you get absolute value of x equals 0. So the next step is we apply the definition. So x equals positive 0, x equals negative 0. Well, positive 0 and negative 0 is just 0. So there's one solution, and it is 0. Okay, so then we graph that on our solution on the number line. So here is 0, and that's where your point is. All right, example 4. Step 1, isolate the absolute value. So we're going to add 3 to both sides. So negative 3 plus 3 is 0, so you get absolute value of x plus 1 equals 5 plus 3 is 8. Next step is we're going to apply the definition. So then that's x plus 1 equals positive 8. X plus 1 equals negative 8. And then next step is we solve. Subtract 1 from both sides. X equals 7. Subtract 1 from both sides. X equals negative 9. Okay, so our next step is we're going to graph our solution on a number line. always put 0 on the number line, so that separates into negative and positive. So the negative 9 is right here, and the positive 7 is right here. All right, example 5. So first step, isolate the absolute value. So we're going to subtract 4 from both sides. That becomes 0. You get 3. Absolute value of x minus 2 equals 6. It's still not isolated, so we're going to divide by 3. 3 divided by 3 is 1. You get the absolute value of x minus 2, because the absolute value of 6 divided by 3 is 2. Now it's isolated. We apply the definition. So x minus 2 equals positive 2. X minus 2 equals negative 2. We solve, add 2 to both sides. X equals 4. Add 2 to both sides. X equals 0. All right, last step, we're going to graph on the number line. Always put 0 to separate the numbers into negative and positive. In this case, 0 is one of the solutions, so we get a point there, and we have a point at 4. All right, last example for this part. Example 6, isolate the absolute value. So we're going to subtract 2 from both sides. So that becomes 0. You get absolute value of x minus 1 divided by 3 equals 10. Now, it's still not isolated, so we're going to multiply both sides by 3. 3 divided by 3 is 1. The absolute value of x minus 1 equals 10 times 3 is 30. Now the absolute value is isolated, and we apply the definition. So x minus 1 equals positive 30. X minus 1 equals negative 30. And we solve. So we add 1 to both sides. X equals 31. And then add 1 to both sides. X equals negative 29. Now, you'll see that my method of graphing makes sense, because if I put a 0 here, you don't have to put a bunch of tick marks. Negatives go on the left, positives go on the right. So negative 29 goes here, and positive 31 goes here. All right, so if you would finish up your examples. Now, you're watching this example on Wednesday, September 19th. So you just finished the examples. Now you're going to tear this page off, and it's going to go, you're going to hole punch it. It should be now hole punched, and you're going to put it in your journal binder, okay? Now you're going to work on these 6 problems. Now, these 6 problems should be finished before class is over. In fact, we should have enough time for you to finish it. I'll check for completion and grade it before the class is over. If not, then we'll check for completion on Thursday at the beginning of class, and then we'll grade it, okay? Either way, you've watched examples, you should be in class on Wednesday finishing up this assignment, okay? All right, so now we move on. Now, it's either at the end of class on Wednesday, or you're now in class on Thursday, okay? And you should be taking these notes, okay? So now let's move on to page 10. Solving absolute value equations, part 3. Okay? Solving by graphing steps. Step 1, isolate the absolute value. Step 2, graph the left side. Step 3, graph the right side. Step 4, find the x values of the intersection. Types of absolute value function solutions. Now, one solution is when absolute value of x equals 0, and the graphs are going to intersect at one point. Excuse me. There's 2 solutions. The absolute value of x equals a positive number, and they're going to intersect at 2 points. If there's no solutions, the absolute value equals a negative number, and the 2 graphs will not intersect. Okay, so finish up your notes. All right, now your notes are finished, and again, this is going to go in your journal binder on page 10. And I'm hoping that you finished this assignment before you moved on to this. So again, you should have finished this assignment. Once you finish that, then you're moving on to these notes. All right, now let's look at the examples. And again, these examples are going to be on page 10. Solve the absolute value equations below. Okay, so first step is isolate the absolute value. It's isolated. Second step, you're going to graph the left side. I'm going to graph these in different colors. I'm going to graph the left in yellow. And I'm going to graph the right in blue. All right. So to graph the absolute value of x, you could easily use your calculator. And to do that, you go to New Document, Add Graph. The absolute value button is right here. Okay, the absolute value right in here. And then you put X, press enter, Control T, and then you have your points. Okay. So let's go and graph those points. So -2, and I'll write them down. So X, Y, so -2 to -1, 1, 0, 0, 1, 1, 2, 2. Now, this is the parent function of absolute value, okay? We're going to use these points as directions on the next couple problems, okay? So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and you can basically go in the same pattern. And I would recommend doing that for the entire graph. And do the points in the yellow and then make the line in pencil. Now, we know from our notes that since the absolute value of x equals a positive number, there's going to be two solutions. Okay, now next step is going to graph the right side. That's a horizontal line of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now you can see it's intersected at 2 points here and here. Now to find the solution, we find the x value. So we go down. Our x value is -1, 2, 3, 4, 5, 6, 7, 8. So x equals -8. And then we go down and find the x value here, 1, 2, 3, 4, 5, 6, 7, 8. All right. Now let's take a look at example 2. All right, so example 2. Now you could graph this, okay? Using a calculator, you'd go New Document, No, Add Graph. The absolute value button is the button next to 9 right here. You'd press enter because that's the one right there. And then it's x plus 1. Press Control T, and then you could graph using the points, okay? So you could do that on examples 2, 3, 4, and 6. But I'm going to show you on this problem and the remainder of the problems. Well, actually, you know what? Let me show you example 2 with the calculator, and then I'll show you example 3, 4, and 6 without a calculator. Okay, so we graph the points, and you could keep going on forever, but notice my farthest point is -5. So our point's -5, 4. So 1, 2, 3, 4. And then -4, 1, 2, 3. -3, 1, 2. -2, 1. -1, 0. 0, 1. 1, 2. 2, 3. 3, 4. And 4, 5. Okay. Now, if you're watching this video and you don't have a calculator, another way you can do this is graph by direction. Okay, and the way we do this is we talk about a parent function vertex, which you know is at 0, 0, and we use a transformation. Plus 1 means we move the vertex left 1. Okay, so there's a new vertex. And then we know the directions are always going to be negative 2, 2, negative 1, 1. This would be HK 1, 1, 2, 2. So you can graph by direction. All right, so from this vertex, we go left 2, up 2, left 1, up 1. There's our vertex. Right 1, up 1, right 2, up 2. Okay, so that's one way to do it. Okay. All right, now we graph the right side, which is at 3, so horizontal 3, so 1, 2, 3. We know since absolute value equals a positive number, we're going to have two solutions. So we see that it intersects twice. So here and here, and now we find the x values. So x is negative 1, 2, 3, 4, so x is negative 4, and x is 1, 2. Okay. Now I know I said I'm only going to show the calculator, but let me show both, but the calculator and the direction. Okay. So finish up example 2. Wait for it. There you go. All right, example 3. Okay. Now this one I'm going to do the opposite. I'm going to graph by direction and then show you can verify it with the points. All right. So to graph the left side, we know vertex is 0, 0. That minus 1 means we go down 1. Okay. And we know our direction is negative 2 to negative 1, 1, k, 1, 1, 2, 2. That's what gives the absolute value shape. So from here we go left 2, up 1, 2. Here we go left 1, up 1, right 1, up 1, right 2, up 2. And then we know it goes in that same direction. Now, that's graphing by direction. Let's verify the points using our calculator. Okay, so use our calculator, new document, no, add graph. Now we press this button right here next to 9. It stays in the one we use, and that's absolute value. And then this is the absolute value of x. Click to the right, minus 1. Make sure I put that in right. Yep. Now you press Control T, and let's check our points. So we know the farthest is negative 5. So we go to negative 5, 1, 2, 3, 4, then negative 4, 1, 2, 3, negative 3, 1, 2, negative 2, 1, negative 1, 0, 0, negative 1, 1, 0, 2, 1, 3, 2, 4, 3, 5, 4. Okay, so there's your two ways you get a graph. You can either use your calculator or graphing by direction. Okay. Now we're going to graph. We know it's the absolute value is equal to 3, so we go up 1, 2, 3. And then we see it intersects twice. Now, I've made a mistake. I forgot to isolate it, but you can actually get away with not isolating and it will still work, but isolating makes it a little bit easier, okay? So here, we know our x values are x is negative 4 and x equals 1, 2, 3, 4. All right, And you can check absolute value of -4 is 4, 4 minus 1 is 3. The absolute value of 4 minus 1 is 3. So these check out. Example 4. So let me take a step back. The first thing you want to do is isolate the absolute value. Okay? So we're going to subtract 3 from both sides. So 3 minus 3 is 0. So you get the absolute value of x equals 0. Now, we know from our notes that when the absolute value equals 0, it's going to have one solution. That's x1. So we're going to graph. Now, this one's easy because we know the absolute value points. Now, these are points, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, because it's the parent function. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And we can keep going here. Now we graph our horizontal line at 0. We see that it intersects only once and at 0, so our answer is x equals 0. All right, example 5, I left out an equation, so let's not waste time doing it. But I just ask that you draw some lines like this, so I don't accidentally mark you off for an incompletion part. Or I can just color the whole thing in, but just some way to mark it out so we know that this is not an example we're using. All right, now let's look at example 6. So first thing we're going to do is isolate the absolute value. So in this case, we're going to divide both sides by negative. And we're going to make that a 1, so divide -1. Negative divided by negative is a positive, so you're left with the absolute value of x plus 1 equals 3 divided by -1 is -3. All right, now we're going to graph the left side by direction, and then we'll use the calculator to verify the points. And again, when you do it, you can either do the direction or graph using your calculator. First things first, that plus 1 means we move the vertex left 1. So there's a new vertex. I apologize for coughing. I think I'm sick, but I'm not sure. I might be. But I apologize for the coughing. All right. So then we know the directions are -2, 2, -1, 1, HK. That's our new vertex. 1, 1, 2, 2. So from here, the difference between points and directions we're moving from the vertex. So we go left 2, up 2, left 1, up 1 from the vertex, right 1, up 1, right 2, up 2. And we know that it should maintain that pattern. All right, and let's verify that those points are correct. So to graph it on calculator, new document, no, add graph, and then we go press the button next to 9, absolute value, and then we're going to put in x plus 1. Oh, almost forgot. No, that's right. Okay, and then control T, and we go farthest to -5. So -5, 4. So -5, 4, that point's correct. -4, 3, that's correct. -3, 2, -2, 1, -1, 0, 0, 1, 1, 2, 2, 3, 3, 4, and 4, 5 is correct. All right, now we graph our horizontal line at -3, so -1, 2, 3. And we knew that because the absolute value is negative, it was going to be no solution, and we verified in the graph because they don't intersect. So example 6 is no solution. All right, so you should have been finishing up this video either on Wednesday or Thursday. And so now you're starting First of all, tear this page off. That goes in your journal binder on page 10. So you should be starting this assignment on either Wednesday or Thursday. And I'm going to check for completion. I might give you 10 or 15 minutes to be in class, maybe, depending on how Wednesday and Thursday go. But either way, I'm going to check for completion on Friday, and then we'll look over the answers and grade it together in class on Friday. So keep that in mind on how you're working through your videos and work on Wednesday, Thursday, and Friday. And so with that, have a wonderful Wildcat